example 1. F of x is going to be 2x over x minus 1, x minus 1 in parentheses, and x plus 2 in parentheses. And I would put a star by vertical asymptotes and by range here, because those are two things that will be kind of unique that I want to point out about this graph. All right, so you got the equation, Charlie? Yeah, it's just 1 x minus 1. I repeated myself. So 2x over x minus 1 times x plus 2. All right. So domain, vertical and horizontal asymptotes, x and y intercepts, range. We'll also want to include, does your notes have increasing and decreasing on it? Okay, we'll also want to talk about that as well. That'll be our comprehensive analysis of the graph. So I would always first start out by realizing, like last time, domain and vertical asymptotes are linked together, because we're going to use all the numbers except what gives us division by what? Yeah, we can't divide by 0. So what numbers give us division by 0? That's right. So for vertical asymptotes, I would say x equals 1 is the vertical asymptote, and x equals negative 2, because that gives us division by 0, and it's undefined there. And many times, I like to kind of do the graph simultaneously as I work through this. So since I know that there's an asymptote at 1 and negative 2, I would go to x equals 1 and negative 2, and I would go ahead and draw those in. And so I put a star there because that's maybe the first one we've done where there's more than one vertical asymptote. Which means what about our domain? It goes from negative infinity What about the middle? Yeah. So, like last time, if there's one asymptote, it divides it into two halves, two pieces. If there's two asymptotes, you'll have three pieces, the left, the right, and then between the asymptotes. Because the domain is all the numbers except that. So you have everything outside on the left, the right, and then everything in the middle. All right, so let's look at our horizontal asymptote like we just talked about last time. The key thing to look at is the degree. So what do you notice about the degree? Which one's squared? Right, you have second degree on the bottom because you're multiplying x times x. So you have the top is less than the bottom. So what case was that? What's going to happen? It's going to be the x-axis, exactly. So y equals 0 or the x-axis. And so I don't necessarily need to draw another line on top of the x-axis, but I could just write over here, that's what it's going to approach. And so each time I put those in there, it's giving me boundaries that the graph is going to approach, kind of a guideline and a framework. All right, y-intercepts. Right, so I plug in x equals 0, see what I get for y. So everybody do that. What do you get? 0, right? 0 over negative 1 times 2 is just 0. So it goes through the origin. Right? Likewise, for the x-intercept, I want to know where does the numerator equal to 0? When does 2x equal to 0? Yeah. So that one point is the only place that it crosses both the x and the y-axis, the origin. So it passes through the origin, but nowhere else. Right? Now it's a pretty bare looking graph in that I only have one point and I have all of these asymptotes. Right? But what we're going to do is we're going to see how these give us kind of a way to eliminate a lot of possibilities and just sketch using a couple points. Okay? So let's look at the far left side, to the left of this. What I know is that the graph, as I get closer to this line, it either has to go up like this or it has to go down like this. That's the only two options. I also know that this y equals 0 means that as I get towards negative infinity, it's going to get closer either from that way or closer from that way, right? So really, there's one other thing that's key here. The key is that there's no other x-intercepts. So it's never going to start at the top and cross this. It's never going to start at the top and cross this line. It's going to be completely enclosed within the x-axis and this asymptote. So it's either up here at the top or down here at the bottom. And so there's one way to test that, and that is just to check an actual value. Check one point and see if it's up here, we'd have option 1 if it's positive. If it's down here, if it's option 2, it'd be negative. So what would be a value that you could plug in? Negative 3 would be a great choice. So if I check negative 3, negative 3 minus 1, negative 3 plus 2, I get negative 6 over 4. Positive or negative? That's negative, so I have it has to look like this option 2. And so I'm going to go back here, right? And then I might as well, to be a little somewhat accurate, plot that point. So I go back here to negative 3, and negative 6 over 4 is negative 1 1/2, negative 3 halves. It's right there. So then I can fill in that entire piece using that one point. Because the asymptotes tell me there's only two options. I check, that's the one it has to be. Let's look at the same kind of idea on the right side. You have the exact same scenario. Can't cross this line, and it has to either go up towards the infinity or down. If we plug in a positive 3, what do we get? 3 minus 1 is 2. 3 plus 2, 6 over 10. So is it on the top or the bottom? It's on the top because our answer is what? It's positive, 3/10. So 1, 2, 3, I get a small number that looks like this. Kind of like that 1 over x graph, right? Yeah, but we still are missing which piece? You're still missing the middle piece. And so there, because we have this intercept, we actually have several options. It could come down. I'm trying to draw them up here. It could come down, touch that point, and go back up. It could come from the bottom, touch that point, and go back down. It could come from the top, go through that, and go down. Come from the bottom, go through that, and go up. How many options is that? 4 different choices, because it could go up or down on the left side, and it could go up or down on the right side, because it could just touch there, or it could go through. So what we need to check is the left side, is it positive or negative when I plug in a value, and the right side, is it positive or negative when I plug in a value. Now at this point, right, you might get tired of plugging in your points, and so one thing you can do, right, is use your graphing calculator as your friend. Your graphing calculator is pretty useful because, one, it will tell you, what it's supposed to look like from the start if you type it in correctly. But you can also use it to evaluate several things. So if I'm going to do 2x divided by, and then I want to make sure I get this all in parentheses, x minus 1 times x plus 2. What's that, twice? Right, it gives me an idea of what it's going to look like here. And one nice thing is that, again, if I hit second trace, oh, I hit the wrong button. Where's trace? If I just hit trace, I think. Yeah, if I hit trace, then plugging in values, like if I type in -3, -1.5, it shows me that same, I could evaluate all those points. If I plug in +3, 0.6, those are the values that we check. And so evaluating this can be sped up. So let's plug in something right to the left of the intercept, to the left of 0, and at -2. So -1. I plug in -1, we get it's +1. So that fact eliminates one option, right? It has to go up on the left side. And then this is where it's even better, right? Because I have to plug in a fraction. But the intercept is at 0, and the asymptote is at 1. So if it's something between 0 and 1, I've got to plug in like 0.5. And so I can see it is negative -0.8. So it's going to go down that direction. So we can finish. The range here is unusual because it's all the real numbers. That middle piece is continuously connected from positive to negative infinity. Mr. Gozen, can you make a sketch of this for Charlie? All right. I wondered if that's a few. What about increasing, decreasing? What's the first piece doing? It's decreasing. What's the second piece? Decreasing. What about the third piece? Decreasing. Yes, that's right. So you could copy the whole domain basically. For space, we'll just say all domain, and increasing nowhere.